Did you know Siemens is the world's largest industrial software company? Yes, industrial software. The German industrial group, known for smart cities, cutting-edge green factories, personal and public mobility solutions, transport, networks, energy solutions, is transforming itself to adapt to the new needs and challenges facing corporations and global CEOs around the world. And to take us through this journey, we have none other than Dr. Roland Busch, Global CEO, Siemens AG, who will help us understand and decode what lies ahead. It's Friday, 5th of July. I'm your host, Arijit Barman from the Economic Times, and you're listening to The Morning Brief. I want to start off with, you're now going to be the CEO for another 5 years. The board has extended your term. Your predecessor, Mr. Joe Kaiser, started this transformation of Siemens, and I met him a few times when he used to come to India. You've continued that path and transformed Siemens from hardware manufacturing giant to a software behemoth. This transformation is easier said than done. Many of your peers, if I look at GE, for example, have failed to do that transition. But on the other side, your revenues are predominantly export dependent. Now, around the world, various economies are making this transition in a gradual way. The way Europe has transitioned, India is yet to. So how do you balance profitability, because you've also achieved highest net profit for Siemens ever? How do you balance that, the company's finances, vis-a-vis this transformational journey of Siemens?
So number one is, you got it right. We believe the DNA of Siemens is technology. Mm-hmm. This is where the value of Siemens sits. And this is even more important in times where digital technologies, AI technologies, large language models are really rolling into all our markets. And our markets are the industrial space, automation, any kind of automation in the world, but also digitalization there for manufacturing, for design. It's about the infrastructure, buildings, the grids. Grids will be automated too, but also the mobility space and the healthcare space, of course, where there's a huge pressure on cost for the healthcare system. Digitalization gives an answer. So therefore, that's a perfect storm. And we have the answers. Technology is the answer to really develop our economies forward. On top comes the energy transition, which requires to go green, which requires a completely new world of more electrified consumption, but also renewables. And this is a package which I believe is perfectly served by Siemens technology. So this is one dimension. The other one is when you mentioned that we are working very much on export-dependent economies, but at the same time, Siemens has a global footprint. We are maybe one of the most global companies in the world. We are almost in all countries and very much localized. Here in India, we have 34,000 people working here, 30 manufacturing sites, local engineering, and even research. So striking the balance, it's a typical management task. You have to allocate capital in your growth areas. The good point is Siemens has reached a very high conversion rate. So that means when we drive our top line, we will see it also in our bottom line. You talked about our 10 billion cash flow, for example. Last year, we were heading for another one, which is a reflection of a high conversion rate and innovative strengths. At the same time, we are allocating 8% of our revenue to R&D, which is a 6.5 billion, which is more than any of our peers in absolute and relative terms. And this is where we are driving innovation. Obviously, we believe that there's a higher return for that since we are allocating capital. But still, it's not good enough to serve the whole technology stack which our customers need. So therefore, we are leveraging also a huge ecosystem, which we are growing as we speak, the tech companies, small and medium-sized enterprises, local companies, systems integrators, in order to really provide the best value for our customers to drive their transformation, their digitalization, but also their trend for going carbon neutral.
Right. Now, you've touched upon some very important points, partnership with technology companies. I was actually surprised when I got to know that Siemens is now probably the largest industrial software company. I mean, you would expect that to be a Microsoft or someone from Silicon Valley, and not Siemens, which is usually linked to German engineering, German manufacturing.
Yeah, I mean, let me get that right. So, and you really phrased it correctly. It's the industrial software. If you talk about software in general, I mean, of course, Microsoft, you have Salesforce, you have SAP, you have others. They are larger, by far larger in size. But the industrial software space, which is about digital design, CAD, CAX systems, it's about simulation software, it's about EDA software where you design semiconductors with, but it's also about software which runs buildings or mobility space. If you take that together, Siemens is I would say, the largest software company in the world. And this goes back many, many years. We cumulative invested over the last 12, 13 years, another 12 or 13 billion euros in building up this software portfolio. So it's not new. It was built up over many, many years. And we continually invested in expanding our software portfolio, organically and unorganically. So that's where we're coming from.
Now we're going to, dive deeper into some of the themes that you talked about, and I want to start with energy transition. Because the COP is coming up in Azerbaijan this time, which is just like last time, a very traditional fossil fuel-driven economy. Now, world over, many would argue that the biggest challenges around climate and energy transition is the fact that it's getting embroiled in policy U-turns or threats of policy U-turns. And the most stark, example is US, where even your colleague, the head of US business, Barbara Hampton, recently went on record to say financial assistance to encourage the revival of US manufacturing should transcend partisan politics. She was talking, of course, about Biden's IRA Act, the CHIPS Act, and the Infrastructure Investment and Jobs Act, which the Republicans are now threatening to repeal. In Germany, which is your home country, we are seeing nuclear plants are getting shut. Germany has actually opened coal mines in the former Ruhr belt. Now, on one hand, we know of Germany as the Angela Merkel's energy transition story, but that seems to be now in tatters. So does politics and energy transition don't go hand in hand?
I do believe that the political system in the world, they all got the message that we have to do something. We are heating our globe. And I do believe this 1.5 degrees are almost embedded. We have to find for any 0.1 degrees increase to get it down. You see that in India. You see that in China, also United States. Depending on the election, that will get a twist. But even if the government, talking about the United States, would, let's say, pull back on this green agenda, I do believe that most companies will continue because they have to invest beyond 4 or 5 years tenure of a government, and they would not invest in non-futuristic technologies. Doesn't mean that there's a lot of capital going also in the hydrocarbon environment. It's a catch-up effect because there was a lot of investment going or hold back, and there's a depletion, so we need it, and there will be hydrocarbons around us. But still, we have to drive this transformation extremely fast in order to change the way how the world runs. The operating system of the world is running too much on hydrocarbons that we know. So now comes, there's a lot of topics behind that. Number one is, this is not a straight line. We still have many countries who are relying on hydrocarbons for many years. I do not believe that Africa will come from nowhere and jump all the way to green. It will not work. And we have to allow them also to make their transition from an emerging economy to a stronger economy in the future. At the same time, we see massive investments in renewables. I mean, sitting in India, I don't know how many gigawatt that will be in solar and wind, and this will be invested. And this is a trend which will not be stopped by any government. It's continuing, but still it will go eventually in a combination. So last point is, it requires a change of our energy system from, I'm always saying, from an OPEX-based model into a CAPEX-based model. OPEX-based means you build a cheap gas-fired power plant and you pay your fuel over the years, over 20, 30 years. CAPEX-based means you invest in a more expensive per kilowatt solar or wind farm, but you have no operating expenses thereafter. So you're pulling ahead investment for the sake of having later on cheaper electrons. So that's happening. That means we have to pull investments up now. That is an embedded inflation in the energy sector, but for the sake of making more carbon neutral and having later the benefit, once your assets are written off, of basically a low-cost energy price. And the costs are going down. You see the photovoltaic modules minus 40%. You see wind is going down. So this is a transformation. I do believe personally nuclear is part of this equation. However, I mean nuclear in terms of modern nuclear power plants, more smaller ones, modular ones, but also they take care about your waste in a better way. But at the same time, renewables are the name of the game.
But the worry is, while there is a lot of investments happening in solar, wind, generating capacity, there isn't that much investment going into battery or storage. And renewable, by nature, is intermittent and it is not fully reliable. So countries like India are actually ramping up greenfield coal power plants. So there is that dichotomy, there is that pulls and pressure, something for the short term. You know, some may say we are missing the wood for the trees. How do you look at it?
And you're fully right. The problem about renewables is they're intermittent. So, and if you run a modern economy, you need electricity 24/7 baseload. You would not build, let's say, a semiconductor plant at a place where you have every other hour a blackout. I mean, that's not working. Even if it's seconds, it will not work. So we do need storage, or we need peaker capacity in the market. And this is a requirement which we see, for example, in Europe or in Germany, that we say once we are ramping up our renewables, we are ramping down coal, we have to increase peakers. These are typically gas-fired power plants, which finally run maybe 1,000, 1,500 hours a year. It's exactly when you need them, but then you ramp it down. This is happening as we speak. I come to hydrogen in a second. Yeah. This happens as we speak. The only problem is, if you want to justify the investment of a gas-fired power plant, which you know it runs only 1,000, 1,500 hours or what, you need a capacity price. You need to price the capacity you provide, because the usage time doesn't justify an investment. This is a regulative thing. The government has to make the regulations in order to do that. And then you can ramp down coal-fired power plants, you bring in peakers, and they run as short as you need to make them run. Needless to say that any kind of pump hydrogen is needed, or should go for. Here comes the point about hydrogen. Hydrogen is basically an answer to the storage of intermittent energy. So green electrons go into hydrogen, to green hydrogen, or any kind of derivative, which is ammonium or methanol. We need that. The only problem here is that this is a massive investment in the future. You need electrolyzers, you need store, you need to distribute the hydrogen, which I would say by 2030 will have in all scenarios, a minimum impact on the overall energy scenario. This takes longer until you really ramp up and get this hydrogen in bulk, so you can really buffer, let's say, the energy demand of Mumbai for a week. So that will not happen. The other one is, if you start connecting grids, they talk about a Europe super grid, where you're connecting grids, then you can also bridge time zones and have renewables feeding in different spaces from different regions. Makes another impact. So there are more. And the last answer is also demand. Currently, we don't control the demand, because power is there. We're ramping up coal-fired power plants if you need it. If you also synchronize the demand a little bit with your offer, then you have another lever. To sum it up, the new energy system is much more complicated than the existing one. The existing one is a one-way street, basically. Demand goes up, offering goes up and goes down. The new one is a network of different sources feeding into the grid, reverse grids which are run completely different, consumers are run differently, and storage on top. If you don't fire on all these different elements, it will be too expensive and it takes too long to make this transformation.
And it also takes billions of dollars. So would you say, to accelerate this transition, governments have to open their purse strings? What America has done, subsidize billions of dollars, which is actually help and have a larger ripple effect, not just on energy transition, but the entire manufacturing, jobs for that matter. That is the model that Europe hasn't used subsidies at all in energy transition. India, doesn't have that kind of a budget. So would you say that the secret sauce to accelerate this transition is government subsidies?
Yes and no. A clear yes if it comes to the grid. I do believe the grid is a base infrastructure which you need, and I believe that's in many cases. I mean, the transmission grids are held by the government. These are core backbone infrastructure which you need to invest as a government. Distribution grid is a little bit different, but even that is a base infrastructure the government has to take care. And then it comes to the feeder. So what kind of power do you need? Here I would say in many cases, and now I'm talking really about the feed-in point, maybe renewables don't need subsidies anymore because they are competitive if it comes to the inflow of electrons into the grid. If it comes to baseload, it's a different element. Here we come again to that might be subsidies, like, for example, providing any kind of subsidies for a capacity market and the like. So that can help for a while. Ultimately, of course, the idea is that the government finally only pays for the base infrastructure, which everybody needs. That's what I believe the government is for, also for mobility infrastructure. But everything what runs on it or what runs into it, that's something which you basically should not subsidize.
Understood. The other mega theme, and I want to get into that as well, is artificial intelligence. Siemens globally has a collab with Microsoft in generative AI. So I want to understand from you, what does the industrial co-pilot do, and how does it help Siemens in developed economies like the US and Europe?
So we have, I give you two ideas, but where we're working. We are working with Microsoft in many different areas of the industrial space and the cloud space. But there are two very nice aspects. One is the industrial co-pilot. Come to that in a second. Another one is we want to integrate Teamcenter, which is our data backbone, our software suite for engineers, for engineering. We want to integrate that into Teams so that when you have a Teams call between engineers, you're working on the same model, on the same digital model seamlessly, and use, of course, also AI technology to really help you driving your productivity and make it much, much easier to work with. That's a nice one too. But coming back to this industrial co-pilot, short version is we want to use large language models to allow shop floor workers to program robots in their natural language. So you finally have a shop floor worker who talks to a robot, give them a task, and this robot is adapting accordingly and fulfills a new task. That's the ultimate target. Currently, it's a co-pilot, so it's always a human in the loop. So it's not that we say, I talk to my robot and it goes. So we have to still have somebody who's checking, is that robot doing the right things? But ultimately, this is the target, and this is the power of large language models, because they make AI technology accessible with your natural language, which makes it much, much easier to use. And that's the magic. And we want to bring that to the shop floor in a hardened application so you can really take it and make it productive on a shop floor.
Understood.
So hallucination is not an option on the shop floor.
Huh? True, but if I look at markets like India, South Africa, Middle East, Southeast Asia, we still have large supply of traditional electrical and mechanical engineers. So how does generative AI coexist with the labor market?
So I think it's a very nice coexistence. We do need mechanical and electrical engineers still, because when we talk, the Siemens strategy is explained very simple. We combine the real and the digital world. Sounds great. That means we use software to leverage the software capabilities on making our hardware more valuable or bringing value to the hardware which we do. But if you listen closely, that means you still need hardware. I mean, you can design software as much as you can. You still need a hardware to drive from A to B. So therefore, you need mechanical engineers, you need electrical engineers. What we do, though, is we make them more productive in giving them, for example, within our simulation tools. We are supercharging them with AI technology from Microsoft or from AWS. We use Bedrock offerings in order to make them more productive. So imagine that you have a new requirement for a train. Normally this comes with tons and tons of specifications. If AI reads the specifications, if AI knows all the designs or has access to all the designs of our trains in the past and gives you a first digital prototype of a model which looks closest to what we already produced and which fits the requirements, this saves us 100,000 of engineering hours, and I can put my engineers on making the fine-tuning to make this train really perfect. So this is the idea what helps.
So let me interject. Are you going to use this, for example, in the recent railway order in India, which is probably the largest you've ever received in the history of the company? 1,200 locomotives of 9,000 horsepower for Indian Railways. Will generative AIs be used in projects such as these?
Not yet. So here we have our guys designing it, our local guys, because it's the local requirements. By the way, it's a 3 billion order, awarded to us in record time, thanks to a government who's really putting this all the processes in place to make that happen. And this is really, this is still hardcore engineering, mechanical engineering, electrical engineering. Still, it's derived from an existing locomotive. Mm-hmm. We have the most selling locomotive, and electric locomotive in the world, our Vectron. So we use that as a base technology and adapt it. The future looks like that you translate requirements into specification documents and finally into automated design. It's still a way to go, but we will get there.
Okay. I was reading that Siemens globally is targeting to raise the share of software and digital business sales of the group to around 20% in the long term. Where are you now in that journey, and where does India figure?
So we're sitting on 6.5 billion, roughly, of software and digital services out of our 75 billion, this is all euros revenue. So there's still a way to go, but this part grows faster. It grows with 10% and more, so we can make the math. We will close that. We will close it organically and inorganically. If it comes to inorganic investments, M&A, we obviously target for software and digital services kind of products, but also connected hardware. Don't forget, connecting really digital world means you have to have hardware which speaks to their software. So any kind of connected hardware is also in the core of our product portfolio, which we want to do. India plays a very important role. We have, out of the 34,000 people which we have here, more than 10,000 are working in the software space. And that's not only offshoring. They are really doing hardcore development. We are transferring, for example, hardcore development of our signaling systems to India, also of designs of locomotives or trains and the like, but also other applications. So we do more and more. India is the place to go if you look for digital talents. It's a vibrant place where you can get the people. And again, the point is, where in the past it was more light software development, offshoring kind of speak. Now we are getting more into the space of really having this deep tech product development done in India. Not only for India, but also for the global market. But also for India, it's a very important, very dynamic market, which requires all the locally designed products.
And one of the subsectors or sub-themes in that probably would be your accelerator program, which is a digital platform. How do you see the prospects of this digital twin in India, where the market still thrives on cheap labor and maintenance is not such a big deal or a big focus as it should be?
First and foremost, just to get for the listeners, get it right. Siemens Accelerator is indeed our digital business platform. It has 3 elements. One is a technology stack, again, from the sensors, actuators, edge devices, up to the cloud and the applications. Number 2, it is an ecosystem. So you don't find only Siemens products on Accelerator, but also our partners' products, applications, hyperscalers, cloud services, but also integration services, and it's a marketplace. So you can inform yourself digitally, but also transact. You can buy a technology stack with a click on this marketplace. So that's about it. Coming to your question on India. India has a target of ramping up the share of industrial GDP from 13-ish to 25% over the next 5 years. In an economy where the GDP grows by 7. So think about how much dynamics you get there. This is all about manufacturing in India, for India, but also for the global market. In this whole resilience discussion of where to manufacture, I do believe India sits on the receiving end, not only producing textiles or any kind of, let's say, commodities, but also high-tech products more and more. Once you start producing more high-tech products, you need also more high-tech manufacturing, more automated manufacturing. Talk about semiconductors. This is all automated. Battery manufacturing, all automated. Even if you talk for automotive car assembly, this goes more automated. So that means more jobs, but different jobs. It means that we have to train the people which we deploy in the industrial space and train them on more the way how you use digital technologies, how you program robots, coming back to that one, how you use digital technologies to program a machine, which machines parts. So therefore, the demand will be there. India will be part of this whole equation, but we need also a very, very solid education and training system for people on the shop floor, but also for the engineers who are running complicated manufacturing sites in the future.
If I look at your quarterly numbers, the last quarterly numbers globally, the robust results were predominantly driven by performance of your grid technology and transformation of industry division. Will this trend continue, or you see new verticals taking the lead going forward?
So if you come to a quarter, that indeed our what we call smart infrastructure business, which is all about buildings, electrical products, energy automation, electrical grids, and that's really, it's growing fast. It was held back by what we call digital industries business, which is more the automation part. This is temporary because we have seen a supercharged super cycle in the last 3 years of a huge demand of automation devices. Maybe the demand was so high that it was not digested completely in the market. So this is an increase of stocking, which we are reducing now as we go. This reduction will go until the end of the fiscal years, and then the market will, or the demand will pick up again. So this is a somewhat temporary thing. If we come to the midterm growth scenarios for Siemens, it's full intact. The demand for digitalization, for automation, but also for going electric and electrifying or sustainable is intact, which is a huge demand. It's tailwind for all our businesses. Digital industries is automation, digitalizing every kind of manufacturing. Is it hybrid? Is it process? Is it discrete manufacturing? Smart infrastructure is electrifying data centers. They're electrifying the grids, the big consumers. Again, battery manufacturing, huge consumer. We are electrifying these plants. And we are developing software which is able to run grids in a way I described it before, much more dynamic, where you have different sources feeding in, you have buffering elements in it. And mobility is the greenest way to move people and goods. Therefore, demand for green transport is increasing as we speak. And in India in particular,
Made an acquisition also recently.
Yeah.
Of an electric charging.
Yes, we made a small electric charging acquisition. We made an acquisition in India for electrical products, and the demand is really giving us a lot of tailwind.
India, what's going to be the growth drivers?
Yeah, I mean, needless to say, repeating what I said before, if you increase in a GDP growing by 7%, if you increase your industrial share from 13 to 25. You know where the growth comes from, number one. Number two is there's a reason why the government was in the last 5 years electrifying 65,000 kilometers of your mobility network. Correct. Another 10,000, 15,000 to go, and then you're done. And the reason is that India, in order to really provide the field for further growth, have to get their transport system in order and make it more productive. The logistics cost in India, they were sitting on 15% of the GDP, which is much too high. You should sit maybe on a 8-ish, 9-ish. And this is addressed by the government in electrifying. So therefore, the demand for more capacity by better and automated signaling technology, but also by more rolling stock. That's a huge demand. And there's another demand for anything what is either new technologies, semiconductor batteries, high-tech manufacturing, we talked about it, or green energy. So we see a huge demand and a huge rise of renewables. The investment is massive. Along with that is an investment in your grids, the distribution grids. Along with that is an investment in any kind of electrical equipment on the receiving end. So therefore, and finally also storage.
We're running out of time for this podcast, but I'm going to ask you, two of the three things that you said, green energy, mobility, in that China has grown leaps and bounds. And we're seeing globally the pushbacks coming using non-trade barriers. US is taxing EVs from China in a big way. EU is moving the same way. We are doing the same. Now, how does the growth on one hand continue or be sustained if you have such strict tariff barriers?
So answering, in the first place, we are against tariff barriers because assuming that you have a level playing field competition and no subsidies or more subsidies than others do, I mean, everybody's subsidizing one or the other, we do not believe in trade barriers because we want competitive technologies to spread around as fast as possible, in particular if it comes to green technologies, because we are sitting on one boat and we have to deploy green technologies as fast as possible. So this is the first statement. The second statement is trade barriers are relevant if you have any kind of imbalance, when you don't have level playing fields. That should be addressed, from my perspective, in a different way rather than increasing trade barriers. In some cases, this is the reaction which our governments do. And then if it comes to Siemens, I have less concerns. We are local. We are in most countries local for local. We have 45,000 people in the United States. We talked about our almost 35,000 in India. Similar number in China. We have 30 manufacturing sites in India. We are fully localized in China, but also in the United States. So therefore, this point of local for local, value added, including in many cases more and more local for local product development, because you have local demands which you have to fulfill with a local development. Doesn't hold true for all products. Some are really global and you scale it. But that's where we are, and therefore we take the growth trends from whatever country they are coming from, and we take them with us. So that's in a nutshell how the world looks like. But I do believe that the trend in governments is really to think about how can they attract more local jobs. And you see that also in India, that the demand for having more local manufactured products is very high. For good reasons. You need to create more jobs in a young population of 1.4 billion people. So therefore, and we are here to serve this trend.
This also links to the whole debate about deglobalization. You know, interest and the rise of the far right across Europe, in America also, even in Asia. Now, recently I was quite surprised to see 10 of the largest German conglomerates, Mercedes, Siemens, many others, come together, some kind of an alliance, to actually tell people to go out and vote. And probably some would read that as go out and vote and don't vote for the far right, because the parties like AfD is becoming very, very strong in a country like Germany.
Yes, it's true that we are gathering some DAX companies, but also small and medium-sized companies. We are gathering in a value alliance, where we are speaking up against shift to the right extreme, I have to say, even to racism, which we definitely have to stand up and fight against. Our system, our democratic system, our free and open markets, liberal markets, they live from diverse culture, from openness, from tolerance. And these are values to be defended. So, and this is the reason why we speak up. The shift to the extreme right wing and racism, even also to the left, but regardless where it goes, is bad because it's basically undermining these values. These parties are very often populist parties. They have simple answers for complicated questions. They never work, but the people want to hear that, and so that they get an attraction. If you take many, many votes to the extreme left and right, they're less and less in the middle. They never end up in government, but still you're thinning out the middle, that you finally end up in a 2, 3, 4-party coalition, which is extremely difficult, as we see in Germany. We have to avoid that. So therefore, we were asking people to vote, because normally the non-voters come from the middle, they don't bother to get voting the extremes. They do go. So therefore, higher voting rate is normally going the right direction. So we do not recommend to vote for any party, but we recommend to go for vote, and we clearly recommend not to vote for parties which are not sharing the values I was talking about.
Dr. Busch, you give us, all of us, hope. We just wish that India Inc. would also take a cue and also play a role in that, because that is also very important in a thriving democracy. Thank you so very much. We traveled around the world. We talked a lot about the global mega trends. It's interesting time, where politics, technology, labor, all of them need to come together. All of them have to play a part. It was really lovely to talk to you. Looking forward to more such conversations in the future.
Likewise.
Thank you.
Nice talking to you.
You were listening to this very special corner room discussion with Dr. Roland Busch on The Morning Brief. This episode was produced by Surohini Jain and Vinay Joshi, sound design by Rajas Naik. Do like, share, and subscribe. The Morning Brief drops every Tuesday, Wednesday, Thursday, and Friday on your listening platform of your choice. So keep listening. Have a great weekend ahead. Thank you, and goodbye.